students, welcome to the Science 1 class. In this video, we are just going to recall some basic concepts about force which you have learned in the class 9. What is force? As we know, force is a push or pull upon an object. When force is applied, stationary objects will move. But this does not explain the concept of force entirely. A ball is lying rest on the ground. Is it stationary? Is there any force acting on it? And the answer is yes. There are forces acting on this ball. There is a gravitational force which is trying to pull the ball towards the earth. And the ground is applying an equal force in the opposite direction, and this force is called as the normal force. As these two forces are balanced, they do not change the position of an object, and the net force acting on the ball will be zero. Just because there are forces acting on an object will not mean that the object will move. For the object to move, there has to be some net force. When a person kicking the ball slowly, what will happen? The position of the ball changes. Why there is change in the position? It's because there was another force acting on it, and the forces were not balanced. The ball moved and there was displacement. Why did the ball stop after covering some distance? Is there any force from the other side to stop it? How it stopped? It was friction that stopped the ball. Imagine that this straight line is a frictionless floor and there is no air resistance. The ball is moving from left to right at a uniform velocity of 2 meters per second. Now, only two forces are acting on it, gravitational and normal force, and the net force will be zero. Will the ball stop moving? No, it won't. It will continue to move along the same direction at the same speed unless another external force acts on it. Here, as the forces are balanced, the ball will continue to move. We will assume that if the object is moving, then there is some net force acting on it. Is it true? An object will continue to move at uniform velocity even if the net force acting on it is zero. We have two important points. First, if the object is stationary and the net force acting on it is zero, then it will continue to remain at rest. Second, if the object is moving at uniform velocity and the net force acting on it is zero, then it will continue to move at the same uniform velocity. So, if the object is stationary, do not assume that there is no force acting on it. And if the object is in uniform motion, do not assume that there is some net force acting on it. So, what is force? A force is a push or pull upon an object resulting from the interaction with another object. Next, we will learn about types of forces. You know that force can be classified as contact and non-contact forces. Contact forces. Forces that result from the interaction of two objects in contact with each other. For example, when you kick a ball lying on the ground, it will move. As you applied force and there was contact. So, applied force is one of the contact forces. The moving ball will stop due to friction. As the ball is in contact with the ground, the frictional force is also a contact force. Air resistance is also a contact force. And the normal force applied in the upward direction is also a contact force. Next, non-contact force. When we throw a ball up in the air, it falls down. What pulls the ball down? Yes, it's the gravitational force which pulls the ball down. This pull happens even if the object is not in physical contact with the earth. So, the gravitational force is an example of non-contact force. Some other examples of non-contact forces are electrical force and magnetic force. Is there forces acting on this rectangular object? Yes. Gravitational force will be pulling it down and the normal force push it up. As the forces are balanced, the net force will be 0. And the object will continue to be at rest unless another external force acts on it. Now, if we push the object towards right side, what will happen? The object will move towards right and it is unbalanced force. And the action of forces are denoted by arrows. And force is a vector quantity. It has magnitude and direction. Suppose, if we are applying 5 Newton force to the object, which of the forces acted on the object while moving towards the right side? The force which we applied, forces of air resistance and friction towards the left side. Then why did the object move towards right side? Here, the upward and the downward force cancel each other. The object moved towards right side because the force of 5 Newton is more than the sum of air resistance and frictional forces which were acting towards the left. Next, inertia. So in simple words, object tends to keep on doing what they are doing. So it's the natural tendency of every object to resist change in their state of motion. If the object is at rest, they prefer staying at rest. If they are moving at a constant velocity, then they prefer staying in motion. This tendency of object is called inertia. It's the natural tendency of an object to resist change in its state of motion. Do you think that all objects have the same inertia? As all objects resist to change their motion, all should have the same inertia, is it? No, it's not. Inertia tells us how strong an object's tendency to resist change in its state of motion. We have two bricks, smaller and larger. Which one would be easier to push? It's smaller brick, isn't it? But why is that? Because the heavier brick's tendency to resist change in motion is more. The heavier the object, the more is its tendency to resist the change in motion. If the mass of the object is more, greater will be its inertia. So, if we apply equal force to both the bricks, the smaller brick will move faster than the larger one. The heavier brick will have more inertia. So, what is inertia? The tendency of an object to resist changes to its state of motion. And the mass of an object is the measure of its inertia. Next, types of inertia. Inertia can be classified into three types: inertia of rest, inertia of motion, and inertia of direction. First, let's learn about inertia of rest. Place a cord upon the open end of the glass tumbler and a coin at the top of the cord. Flip the cord horizontally. What will happen? Cord moves away and a coin will drop into the glass tumbler. Why coin is not moving along with the cord? Both the cord and coin are in the state of rest. With the external force, cord changes its state, but coin can't change its state immediately. So the resistance of the body to change its change of state is called its inertia of rest. Next, inertia of motion. When a moving bus stops suddenly, passengers standing inside the bus tends to fall forward. It's because the lower part of the body comes to rest along with the bus, while the upper part tends to continue its motion due to inertia of motion. The resistance of the body to change its state of motion is called inertia of motion. Next, inertia of direction. Tie a stone to one end of a string and move it rapidly in a circular path. And when the string breaks, the stone will move along the tangent of the circle. And the inability of the stone to move along the circular path is due to inertia of direction. The resistance of the body to change its direction of motion is called inertia of direction. Okay students, that's all for today's class. In this video, we have learned few concepts about force and inertia. Thank you students. Have a good day.